it is given z, show z. We can see that it is given the first derivative and the second derivative arises, so we can guess that we need just differentiate a given equation. And we can see that the left hand side it's a product of two functions, the first and the second, so we should apply a product rule, and we differentiate with respect to x, and y is a function of x. So derivative of 5x plus y becomes 5 plus dy dx and multiplied by just dy dx plus 5x plus y. Derivative of the first derivative is just the second derivative, is equal to derivative of x, it's 1 plus 5 dy dx. And we just move this to the right and get 5x plus y, the second derivative, is equal to 1 plus 5 dy dx minus, and open parentheses, and we get minus 5 dy dx minus dy dx multiplied by dy dx. Notice that it's dy dx squared, not the second derivative. Don't get confused. And we can see that it cancels and we get as required. The next shows that, and we can see the third derivative, so we just differentiate it again. And again we consider it as a product and apply a product rule, so it becomes 5 plus dy dx multiplied by the second derivative plus 5x plus y, and derivative of the second is the third derivative, is equal to derivative of 1 is 0 minus, and it looks like some function squared, and we apply a chain rule, and it says that some function squared derivative is 2 times function and function derivative. Hence it becomes negative minus 2 dy dx and multiplied by dy dx derivative, which is the second derivative. And again move it to the right and get that 5x plus y, the third derivative, is equal to negative 2 dy dx multiplied by the second derivative minus, and open parentheses, minus 5 the second derivative, and minus dy dx multiplied by the second derivative. And we can see that there are like terms, and finally it's just negative 3 as required, and minus 5 the second derivative. And the next, find the Maclaurin expansion for y up to and including the term in x cubed. A formula is y is function is 0 plus derivative is 0 multiplied by x plus the second derivative is 0 multiplied by x squared over 2 factorial, which is just 2, plus the third derivative is 0 x cubed over 3 factorial, which is 6. So we can see that we need function at 0. It's given that when x is 0, y is 2, so it's 2. Derivative at 0. To find it, we consider this expression and consider when x is 0, because we need the value when x is 0. We need a y and derivatives at x is 0. Hence it becomes 5 times 0 plus y of 0 dy dx, it's the first derivative at 0, is equal to 0 plus 5y of 0. Y of 0. And it's 0. We need this. And y of 0 it's 2. So it becomes 2 multiplied by derivative at 0 is 5 times 2, and we can see that the first derivative at 0 is 5. So it is found. It is 5. And to find the second derivative, we consider the next expression where there is the second derivative, and again consider when x is 0. So it becomes 5 times 0 is 0, y of 0, and the second derivative of 0 is equal to 1 minus it's the first derivative at 0 squared, and y of 0 is 2, 1 minus the first derivative is 5 squared. Hence, the second derivative at 0 is 1 minus 25 negative 24 over 2. It's negative 12. It's negative 12. It's 0. And we need just the third derivative at 0. So consider this at x is 0. So it becomes y of 0 multiplied by this third derivative at 0 is equal to negative 5 the second of 0 minus 3 the first derivative of 0 and multiplied by the second of 0. Y the third, negative 5 the second, minus 3, and substitute. Y of 0 is 2, the third derivative, negative 5, the second at 0 it's negative 12, minus 3, the first at 0 it's 5, and the second at 0 it's negative 12. And the third derivative is 0, just divide each term by 2, and it becomes negative 6 here, so it's 30, and negative 6 minus plus, it's 30, and times 3, 90 plus 90, so it's 120. 120. Hence, the required value of y becomes y of 0, 2 plus 5x negative 12 over 2 negative 6x squared, and 120 over 6 it's plus 20x cubed. And that's all for this question.